In this video, we are going to see steam nozzle related problems. Myself, Rajkumar, Assistant Professor, Department of Mechanical Engineering, Rohini College of Engineering and Technology. Problem: steam at a pressure of 10.5 bar and 0.95 dry is expanded through a convergent divergent nozzle. The pressure of steam leaving the nozzle is 0.85 bar. Find the velocity of steam at throat for maximum discharge taken n equal to 1.135. Also find the area of the exit and the steam discharge if the throat area is 1.2 centimeter square. Assume the flow is isentropic and there is no friction losses. This is the problem. Use steam table only. First of all, we read the problem and understand all the datas. What are the datas they are given, and what we are choosing the best formula for the particular problem. So we can solve this problem by the different method. By by using the best method, we can easily find out the answer. Okay, so first of all, the given data: steam at a pressure of 10.5 bar, that is the pressure at initial P1 equal to 10.5 bar, and 0.95 dry is expanded through a convergent divergent nozzle. This problem is convergent divergent nozzle. This is the first point. So in this steam nozzle, we have the three types of problem is there. One is convergent, another one is divergent, another one is the combination of convergent and divergent nozzle. These types of problem is convergent divergent nozzle. First of all, we have to find out the which type of nozzle. Okay, this problem is the convergent divergent nozzle. Then the pressure of the steam leaving the nozzle is 0.85 bar. First of all, we should draw the convergent divergent nozzle. Then indicate the number, that is the initial condition and throat condition and final condition. Initial condition means 1. That place the pressure value is P1. Okay, the velocity value V1. Then intermediate, that is throttle place is a 2. That place pressure value is P2 and velocity value is V2. Then exit condition is the 3, that is the pressure value is P3. So here they are given the exit pressure, that is a P3 value they are given, that is 0.85 bar. After that 0.95 dry. So the initial condition, the condition of the steam, we are having the three types of steam, that is a wet steam, dry steam, superheat steam. First of all, we find out the which type of steam. So here they are given directly 0.95 dry means the condition of the steam is wet steam. That means the condition of steam straightness fraction value 1 means the steam is dry steam. Okay, then find the velocity of the steam at throat. So intermediate velocity they are asking. After that they are given the n value index, that is a 1.135. Also they find out the area, that is a area at the exit, that is the final condition of the area they are asking. The steam discharge if their throat area is 1.2 centimeter square, that is A2 they are given 1.2 centimeter square. Assume the flow is isentropic, they are given isentropic process, that means S1 equal to S2 is equal to S3. Okay, that is the entropy remains constant. There is no friction losses, they are given, consider as there is no friction losses. Okay, then we are going to solve the problem. First of all, the pressure P2 at throat for the maximum discharge is given by P2 equal to P1 into 2 divided by n plus 1 the whole raised to n divided by n minus 1. They are given the value of P1 value and n value. So from that we have to find out the P2 value. Substitute all the values in the P2 P2 formula. So we get the value P2 equal to 6.1 bar. Then the velocity of V2 at the throat for the maximum discharge is given by V2 equal to 2gc into n divided by n plus 1 P1 V1. Then V1 equal to x1 Vg1, that is specific volume at wet steam at inlet. inlet they are given the wet steam. So we to find from this formula we can find out the V2 value, that is we get the value V2 equal to 443 meter per second. Then as the flow is isentropy, so we S1 equal to S2. So we know the condition of steam. The condition of the steam is the entropy remains constant is so S1 equal to S2. We know the wet steam formula SF1 plus X1 SFG1 equal to SF2 equal plus X2 SFG2. So we know the values all the SF1 SFG1 from the steam table, pressure P1 pressure and P2 pressure. So from that we have to find out the X2 value, that is the dryness fraction at the throttle condition X2. So from that we have to find out the enthalpy at the intermediate and initial. That's we know the formula for the wet steam, H equal to HF plus X HFG. So here the H1 equal to HF1 plus X1 HFG1. So HF and HFG1 we can directly take the data from the steam table at pressure P1. Then H2 value equal to HF2 plus X2 HFG2. This HF2 plus HFG2 the values directly taken from steam table from related to pressure P2 pressure. So now V2 can be calculated using the formula V2 equal to 445.72 root of square root of H1 minus H2. We know the value of H1 H2. From that we have to find out the intermediate velocity V2. Then mass M equal to M A2 V2 divided by X2 Vs2. So Vg2 we know that directly we can specific volume of dry steam at 6.14. So from that we have to steam table we have to find out the 0.31 2 meter per kg. From this value we know all the values from so this formula we have to find out the mass value equal to 0.186 kilogram per second. Similarly expansion 2 to 3 is also isentropy. So S2 equal to S3. We know the S2 value, S2 formula is wet steam. So we know S3 also wet steam. From this formula we can find out the X3 value. X3 value we know means we can find out the H3 value. H3 means enthalpy of at exit condition, that is H3 equal to HF3 plus X3 HFG. From that we have to find out the enthalpy H3. Then V3 we can to find out the velocity at the exit V3 equal to 44.72 root of H2 minus H3. We know all the value, so we can find out this formula V3. So finally we have to find out the exit area. So we know the formula for the mass at the exit M equal to A3 V3 divided by X3 Vg3. From this we have to find out the A3 value. So A3 equal to 3.7 into 10 power of minus 4 meter square, that is 3.7 centimeter square. Thank you.